I have to apologize, I had a software glitch. I thought my program had crashed when it really hadn't. So now we have a three-part video continuing our oxidation exploration of hydroboration oxidation. We've generated a second O- and a rearranged molecule where carbon is now bonded to this oxygen instead of carbon bonded to boron. I promised that the first two times you generated O-, they would do exactly the same thing. So let's review what we did the first time. The first time after we made O-, we attacked the very positive boron. I want to point out the boron is even more positive now because it has a new bond to oxygen, a very electronegative atom. So this step will be very quick. Lone pair attacks the boron, generating a fourth bond to boron, and you know what that means in terms of formal charge. You guessed it, the boron now has a -1 formal charge. So step 4 created a fourth bond to boron with a new oxygen. Step 5 gets rid of one of those bonds to oxygen, but this time it's the other oxygen. It's basically what's happening between steps 4 and 5. We're trading oxygens off of the boron. This is very typical of the reactivity of boron. It's a little machine that alternates between 3 bonds and 4 bonds. And the little machine is going to go down to 3, and you know what that means in terms of formal charge. You guessed it, the boron is back to having no formal charge. And if you take a quick look at this compared to the final product, you'll see that this is the conjugate base of the final product. This oxygen on boron becomes an O- on boron. You guessed it, and you were told it 2 times. Step 6, just like step 1, is an acid-base step. Step 6, lone pair on oxygen attacks proton. Sigma between H and O becomes a lone pair on O, giving this result. We've got our first molecule of antiMarkovnikov alcohol. We've generated a boron with a resonating O-, that's a borate derivative. For you, the mechanism is over, but as an instructor, I have to tell you that this reaction is going to happen 2 more times with this species to generate 2 more alcohols. And the mechanism is the same every time, so I'll summarize it quickly here and then give you a test version below. So upon repeating steps 1, 2, 3, 4, 5, 6, in this case it will go even faster because this boron has a bond to O compared to the original boron, which did not. So the peroxide anion would attack this boron even more quickly than it attacked the first boron. And the reaction would proceed nicely to make 2 more molecules of alcohol and the molecule called borate. So that is the end of the mechanism. On a test, I would test you this way, and I will have the full mechanism summarized down here. So on the test, I'll have the first 2 reactions already completed. You will only show me the 3rd time you make the alcohol. Once again, acid-base step 1 and step 6. Although I haven't shown the arrow yet for step 6, might as well do that while I'm here. Grab the proton. Sigma becomes lone pair. So, step 1, acid-base, generates an O-. The first 2 times you generate an O-, you attack a neutral boron atom. Making a 4th bond to a boron always generates an anionic formal charge on the boron. In step 3, we rearrange the carbon-boron bond to a more stable carbon-oxygen bond. And more importantly, something I didn't even mention, the reason peroxides are so reactive is lone pair repulsions on adjacent oxygen atoms. They do not like being like this, oxygen atoms. So we got rid of the OO bond, and both oxygens are much more stable as a result. Anyway, the rearrangement generated this neutral boron species. Once again, charge 0 boron, -1 boron, 0 boron, -1 boron, and you're finished when you get to what kind of boron? A neutral boron. No formal charge on the boron here. I think some of you may have spotted a fatal flaw in here that doesn't match up with step 5 above. I will fix that and see if you catch what I did. In step 5 up here, we simply broke the boron-oxygen bond, obtaining a neutral boron here and an oxygen anion here. Then in step 6, as promised, we have an acid-base step, but this is the proton I need to attack here. And once again, the boron went from -1 in this step to no formal charge in this step. And the lone pair on this oxygen is going to do an acid-base react. Lone pair on oxygen grabs the proton. Sigma bond between O and H becomes a lone pair on the O, generating the borate ion right here, and the antiMarkovnikov alcohol right up here. And that finally is the end of this arduous mechanism. It's going to take a lot of practice to get this down. Take comfort in knowing that it will be on your exam. Not maybe, it will be on your exam. You'll be graded for a full 10 points down here. 6 steps. A lot of patterns involved. Over here I'm going to summarize the 2 videos worth, which ended up being 3 videos worth of reactions, so that we can see where we started and where we ended before we close. In conclusion, we take an alkene and react it with borane. We get a Markovnikov trialkyl borane. 3 moles of alkene, 1 mole of borane give 1 mole of trialkyl borane. Treatment with hydrogen peroxide, sodium hydroxide, and keeping in mind excess stands for excess. The word EXCESS means there's extra hydroxide and peroxide. So that we can do this 3 times and make 3 alcohols. They're now anti-Markovnikov, but not having anything to do with the alkene. We get an anti-Markovnikov alcohol because we tricked our alkene after the fact. We first put a boron on the less substituted carbon, which was Markovnikov, and replaced it with a more electronegative oxygen. And I hope these 3 videos have helped you understand hydroboration oxidation, a very important reaction.